Hi, everyone. It is your friendly, Kool-Aid obsessed Ian Padden here. And what I'm bringing you here today is a technical paper that I was asked to write by my geometry teacher. Hi, Mr. Elias. I'm sure you're watching this right now. So, the problem that was presented with us is find k if the distance between point A, which is 3 comma k, and point B, which is negative 10.5 comma 13.5, is 15.5. Now, this may look a little intimidating, and it might get a little worse in a second, but I promise, this problem is not at all as bad as it seems. I was frankly intimidated by it at first, but the way that we're going to solve it is just by using the distance formula. But instead of attempting to solve for the distance, all we're going to do is solve for just one of the variables in it. So to start out the problem, we're just going to go and fill in the variables that we do know, which will leave us with this. 15.5 is equal to the square root of negative 10.5 minus 3 raised to the second power plus 13.5 minus k raised to the second power. Now, I know what you're thinking here. Oh boy, Ian, this is going to be quite the problem, isn't it? It's actually not. Really, what's probably making you think that is that big square root we can see right up there. And that's actually the first step on how we're going to solve this is we're going to get rid of that square root. So to get rid of the square root, all we do is just square both sides of the equation. Square and get the square root away. Luckily, this isn't a problem where we have to solve any shapes or anything, so it's not going to be a square, which is squaring that square to get rid of the square. See what I did there? So anyway, squaring both sides of the equation will leave us with this. 15.5 raised to the second power is equal to the same thing as before. Now, as we can see, squaring both sides didn't at all change the second side besides just removing that square root, which is a good thing. But from here, all we're going to move on to is just doing a little bit of basic math, which is just taking the 15.5 raised to the second power and solving that, as well as subtracting negative 10.5 minus 3, which will bring us to this. 110.25 is equal to negative 13.5 raised to the second power, plus 13.5 minus k raised to the second power. As we can see here from we started before, this problem has become a lot less complicated, which is a really good thing. From here, all we're going to do is just solve the negative 13.5 raised to the second power, which brings us to this. 110.25 is equal to 182.25 plus 13.5 minus k raised to the second power. And already, we're winding down to the last steps of our equation, which all we're going to do from here is subtract 182.25 from 110, which gives us the lovely number of 72. Now, as we can see here, things might look a little odd. 72 looks fine, and you might think to yourself, if you haven't done a problem like this before, hey, Ian, all we're just going to do is subtract the 13.5 from both sides, right? Wrong. That is not at all the correct thing to do. What we would want to do here is square both sides again by a square root to remove the second power, but we can't do that. Because you see, you can't square a negative. It just doesn't work. And therefore, our problem is no solution. As we can see here, lovely pasted at the bottom, we end off with negative 72 is equal to 13.5 minus k raised to the second power and no solution.